Hello friends, myself Mrs. Vaishali Harak, Assistant Professor in Electrical Engineering from MPP Samaj's KBT College of Engineering, Nasik. Today we are going to discuss electrostatic or electric field. Now electrostatic field is an electric field which is produced by the static electric charges. Or I can say that electric or electrostatic field, it is a region around a charged body where another charged body experiences a mechanical force. The lines of force come out from positive charge and move towards this negative charge. Now also there are some laws like Coulomb's law. Coulomb's first law states that the like charges repel each other and unlike charges attract each others. Also there is a second law, this is called as inverse square law. It states that the force between the two charges, that is q1 q2, separated by distance r, it's proportional to the multiplication of charges and inversely proportional to square of the distance between them. So F equals to a q1 q2 upon r square, where a it is a constant of proportionality 1 upon 4 pi epsilon, where epsilon it is a permittivity, or I can write that F equals to q1 q2 upon 4 pi epsilon 0 epsilon r square. The value of epsilon 0, it is a constant, it is 8.854 into 10 raised to minus 12 farad meter. Now some basic definition related to electrostatic field. The first one is electric flux. Now electric flux, it is defined as the number of lines of force in any particular electric field, and it is measured in coulomb. So electric flux, which is denoted by psi, which is equal to q coulomb. Now second one is electric flux density, which is denoted by capital D. Now it is defined as the flux per unit area measured at right angles to the direction of flux. So we can calculate D equals to psi upon area, which is equal to Q upon area. Unit is coulomb per meter square. Now third one is electric field strength or electric field intensity, which is denoted by capital E. It is defined as the mechanical force by a unit positive charge where it is placed at that point in electric field. Now this E, it is F upon Q, or unit it is Newton per coulomb. Now D, it is directly proportional to E. D equals to, when I remove that proportionality sign, D equals to epsilon E, or D equals to epsilon 0 epsilon R into E. Now next it is permittivity. Permittivity, which is denoted by epsilon. Now permittivity, it is the age with which the dielectric material acting as a medium, or I can say that it is a property of a material which allows the electric flux to establish in it. Now permittivity, it has three types: absolute permittivity, permittivity for free space, and relative permittivity. So absolute permittivity, it is the ratio of electric flux density to the electric field strength. So epsilon, it is D upon E, or our unit is farad per meter. Now permittivity for free space, which is denoted by epsilon 0. So it is the again ratio of electric flux density to the electric field strength, but medium is air or vacuum. So epsilon 0, it is D upon E, and the value is fixed, which is given by 8.854 into 10 raised to minus 12 farad per meter. And third type, it is relative permittivity epsilon R. Now it is defined as the ratio of electric flux density in dielectric medium to that of produced in a vacuum or a free space by same electric field strength E, and with all other conditions identical. So epsilon R we can write as D upon D0. So epsilon R equals to, when I put value of D and D0, it is epsilon E upon epsilon 0 E. So epsilon equals to epsilon 0 epsilon R. Again for air here epsilon R is 1. Now what is the capacitor and condenser? Now capacitor or condenser, it is an energy storage device in electrostatic field. We can store the energy in electrostatic field by using this capacitor, or it is also called as condenser. So it is formed by two conducting plates or surfaces separated by some insulating medium, or it is called as dielectric medium. So in figure it shows two conducting two conducting surfaces are there, or can say two conducting plate, and separated by this dielectric medium. D it is the thickness of that medium. A it is area of cross section. Now material used for dielectric medium as mica, glass, paraffin paper, polystyrene, oil, etc. So capacitor, again these are classified as fixed capacitor and variable capacitor. Fixed capacitor means whose value is fixed, and variable capacitor means we can change the value of that capacitor. Now capacitance. Capacitance, it is the property of a capacitor to store the electric energy in the form of static charge, or it is also defined as the amount of charge required to produce the unit potential difference between the plates of capacitor. The unit of capacitance is farad. Now Q it is directly proportional to V, so Q equals to CV. So capacitance C equals to Q upon V. So capacitance of a parallel plate capacitor, we can calculate the expression for that. We have the flux psi equals to Q coulomb, electric flux density D equals to psi upon area, or which is equal to Q upon area. Electric field intensity capital E equals to V upon D. We have D equals to epsilon into E. Now D equals to, I can put that value Q upon A, which is equal to epsilon V upon D. So Q upon V equals to epsilon A upon D. Now Q upon V, we know that it is a capacitance. So C equals to epsilon A upon D. Epsilon, we have put epsilon 0, epsilon R. So C equals to epsilon 0, epsilon R, A upon D. So this is the expression for capacitance. C equals to epsilon 0, epsilon R, A upon D, where A it is the area of cross section, D it is the thickness of that dielectric medium. Right? And this capacitor, it is measured in farad. So this is about general concept related to electric field. Thank you.